So today we're going to learn the next method, which is Systems Method 3, Classic Substitution. So yesterday we learned about setting equal. And we talked about how if two numbers, so if 2 plus 3 is 5 and 1 plus 4 is 5, and since 5 equals 5, then whatever 5 is equal to is equal. I've said equal a whole bunch of times. But we're going to do something a little different this time. So I'm going to give you another example. So let's say I have y equals 2x plus 7, and I tell you that x equals 5. How would we solve that question? Well, what we would do is I would take 5 and I would substitute it in. So I would take my 5. So I have the x here and an x there. So I would take that 5, and anywhere I saw an x in the other equation, I would plug it in. So I would say y equals 2 times 5 plus 7, which means y is 17. Okay? So that's how we would solve it if we had a number value for x. Well, now what we're going to do is we're going to have another equation that we're doing that same substitution for. Now, before you go, now what? Just relax. Okay, it's not that bad. Okay? So again, we're going to look at this equation. We're going to write an equation first, and then we're going to solve it. Now, I know you're thinking, again with the equation, again with the word problem, but it's not that bad, okay? So this is a rectangle has a perimeter of 16 inches. Now, first of all, I'm going to tell you that perimeter equals 2L plus 2W, okay? Because that's the formula for perimeter. Its length is 3 times its width. What are its dimensions? And by the way, dimensions are length and width. So like anything you can measure is a dimension. Area and perimeter are things that we calculate. So measurements are things we calculate. Dimensions are things we measure. So like the sides of a figure, the perimeter, I'm sorry, the length, the width, the height, the radius, things that we measure. Okay? So when they give me a question, the question tells me what my variables are. Okay? So my variables are length and width. So I'm going to say L equals length and W equals width. Now, you may be thinking, but why aren't you using x and y? Because I don't want to use x and y. And I don't want to use x and y because if I say that x is length and y is width, then I'm always going to be having to go back and forth and be like, okay, like, what's width? What's length? I'm going to have to always be going back and forth and trying to figure out which one it is. If I say it's L, L can only be length and W can only be width. Okay? Now I got to write my equations. So it says perimeter is 16 inches. So perimeter is 16 inches. Well, I know that the formula for perimeter is 2L plus 2W, so 2L plus 2W equals 16. Now, this one's tricky. We need a caveman sentence for this one. It says its length is 3 times its width. So length is 3 times width. So that means L equals 3W. Okay, L equals 3W. Those are my two equations. Now, if you're struggling with writing equations, we can work on that another time. For now, I just want to focus on this skill, which is substitution. All right, so here's what you're going to do. That's right, highlighter. Deal with it. You know I love them. This is what I want to see. If I don't see this highlighting, whatever, if I don't see it, I'm going to be like, okay, so what you're going to do is, I see that I have a variable by itself. It's L, so I'm going to highlight that L. Then I'm going to go to the other equation, and anywhere I see an L, I'm going to highlight it there too. Okay? Okay, so I've highlighted the L that's by itself, and then I'm highlighting it in the other equation too. Whatever it's equal to, I'm going to circle, and anytime I see that highlighted L, I'm going to put that instead. So instead of putting, so just like up here, anywhere I saw an X, I put a 5. Now, anywhere I see an L, I'm going to put a 3W. So let me show you what that looks like. 2, well, I see an L. So what am I going to put in its place? 3W. Plus, and then I'm going to keep going. Whatever else is left, I'm going to keep writing it. So I just substituted in 3W for L. And remember, anytime I substitute, I want to put it in parentheses, just like we've always done. And then I'm going to keep writing. So 2 times L, which is 3W, plus 2W equals 16. And now I'm going to start to solve. Now let me tell you the reason why we use substitution real quick. So you're like, why are we doing this? We're doing this because we can't solve an equation when it's got more than one variable. Like right here, if I try to solve for my length or my width, all I can do is rearrange it. I can rewrite this in terms of L, but it would just be another equation. I can rewrite this in terms of W, but it's just going to be another equation. That's not going to help me figure out what they are. The only way I can solve and get a number is if I've only got one variable. So if I'm trying to find two variables, I have to have two equations. If I was trying to find three variables, I'd need three equations. So I have to have that many, and so the whole point of this strategy, the whole point is I am trying to get rid of a variable, but I have to use the rules of algebra to do it. And so substitution is one of the things I'm allowed to do. If I know what L is, anywhere I see an L, I can plug it in. Now all I have are W's, so I can figure out what W is worth. So now I'm going to distribute this. So 2 times 3 is 6W, and then I keep writing. So I'm doing this part, plus 2W equals 16. Well, 6W plus 2W is 8W equals 16. And when I divide both sides by 8, I get W equals 2. So what does that mean? What's 2? Well, W is 2, that's width. Okay, that's why using variables that match the situation is so useful, because I don't have to be like, was width X or was it Y? I know it's W, it's width. They're never going to mix them up, and they're going to give you these backwards. So they would give you whatever width is and whatever length is, and they'd give them mixed up in answer choices. Okay, so now that I know what the width is, I still got to figure out what the length is. Well, look at that. I can, just like up here, I know what width is too. Now I know that W equals 2, and that length is 3 times W. Well, I can do that same thinking. Where'd my highlighter go? Okay, well, if I have W equals 2, and length is 3 times the width, then I can say length is 3 times 2. That means the length is 6. Now, the beauty, like I said yesterday, the beauty of systems is I have an opportunity to check, okay? So I use this one to find the length. Now I can use this last equation to check and see if it works. Well, so first of all, it says here, is the length 3 times the width? Well, the width has to be longer, right? Is 6 3 times 2? Yes, 6 is 3 times 2. Well, is the perimeter 16? Okay, well, 2 times the length, which I said was 6, plus 2 times the width, which is 2. And again, I'm just using this formula right here, should equal 16. Well, let's see what my calculator says, because again, I don't like to be wrong. 2 times 6 plus 2 times 2 is 16. It's right. And so now I know my length and width are 2. And again, this is the reason why I like to use variables that match the situation. Now, if you don't like them, that's fine. You can still use X and Y, but you just have to make sure that you always keep track of which variable is which. All right? I'm going to do 2 examples with you. We're going to save the third one for you to do in class. So to start off, I want you to highlight. Just take a moment and highlight, so I can see which ones that you know you know what you're substituting in. So you're finding the isolated variable, and then you're highlighting it both in the equation it's in, and then in the other equation. Take a moment to do that now. Okay, so in the first equation, I have an isolated variable. Remember, isolated means a variable by itself. Okay, so I'm going to highlight that isolated variable, and then I'm going to find it in the other one and highlight it there too. The same letter. I'm looking for the same letter. Okay. Now, anywhere I see a y, I'm going to put 2x instead. So I start, in this equation here, I start 7x minus, and then I'm going to make parentheses, 2x equals 15. So again, all I did was substitute in there. Nothing else. Okay? Well, 7x minus 2x is what? It's 5x. I divide both sides by 5, and I get x equals 3. So I think that x is 3. Now remember, for a system, I'm trying to find a solution. A solution is an ordered pair. It's not just x, it's x and y. So I got to take that x and use it to find y. Well, I'm going to be honest with you. This is easier. I mean, I could plug this x in here, but then I got to do a whole lot of equation work to find it out. If I substitute it into this one, it's easy. I say y equals 2x. That means y equals 2 times 3. y equals 6. Is that right? Yeah, that's right. Okay. Now, I'm going to check it. So I'm going to use this equation here to confirm that I'm right. So 7 times x, which I think is 3, minus y, which is 6, should equal 15. So let's check it out in our calculator. 7 times 3 minus 6 is 15. It worked. So I know that my solution is 3, 6. All right? Okay. I want you to, once again, I want you to find the highlighting real quick, and then I want you to do the first substitution step. Take a minute and do that right now. Okay, so again, my variable that's by itself is a y. Is it always going to be a y? No, because right here it's an x. Okay, sometimes it's x, sometimes it's an L, sometimes it's some other letter. It's just whatever letter's by itself. That's when we use this method substitution. Well, I highlighted it here, so anywhere else that I see a y, I'm going to highlight it in the other equation too. And now, anywhere I see a y, I'm going to stick a 2x instead. So 4x minus 2 times y, which is 2x, equals 16. Okay? Now, I got to distribute this to solve it. 4x minus 4x equals 16. Well, 4x minus 4x is 0. Okay, this is weird. All I have is number equals number. Well, does 0 equal 16? No. So I have no real solution. Okay? So again, remember, real matters, but we're going to not really understand why it matters as much until we get to Unit 4 and 5. Okay, so don't stress too much about that. I was going to let y'all keep this one, but I'm going to do this one because this one does look a little different. What's different about it is in this one it was just y equals 2x, y equals 2x. Well, now I've got like a whole equation, a whole bunch of, I got 2 terms over here. But the process is the same, okay? This one has a variable by itself, x. So I highlight that. Then I go to the other equation and I find anywhere I see that variable, and I see it right there. Now what this means is this time I'm going to take 2 minus y and plug it in anytime I see x. So I have 3 and x, which is 2 minus y, plus 2y equals 36. Now I distribute. Again, now I'm just solving the equation. And again, since I only have one variable, now I can find a number answer. 3 times 2 is 6. 3 times negative y is negative 3y, plus 2y equals 36. Now I need to combine my like terms. 6 minus 1y equals 36. Subtract 6 from both sides to isolate the negative 1y. Big mistake I see you guys make right here. You bring down the 1y, but you forget about the negative. Remember, that matters, okay? I divide everything by negative 1, and I get y equals negative 30, okay? If this was an inequality, I'd be flipping the sign, but it's not, so I'm not worried about that. Okay, so my y is negative 30. Remember, I don't just want to know what x is, I want to know what y is too. I just want to know y, I want to know x also. So I think y is 30, but I need to come back. Again, I could plug that y in here, but it's going to be easier here because if I just plug in the y, I get the answer. Okay? So I have x equals 2 minus y. What's y? Negative 30. Notice, since I plugged it in parentheses, I didn't forget about the negative. Okay? And again, if you're like, I don't know what that is, put it in your calculator. 2 minus negative 30 is 32. So x is 32. You don't have to check it, but I would strongly recommend that you do that. And we're going to do that right here. I'm just going to kind of do like that. 3 times x, which I think is 32, plus 2 times y, which is negative 30, should equal 36. Well, let's plug it into our calculator and see. 3 times 32 plus 2 times negative 30 equals 36. So I'm right. So my solution is 32, negative 30. And again, notice, it doesn't matter which one I get first. X goes first, then y. Even though I found y first, I still write my ordered pair as x comma y. Come with questions tomorrow. If you have any, please go ahead and write them down right now.